Hello, I'm Jared P. Lander. R and data science is a huge part of my life. In addition to owning a boutique data science firm in New York City that specializes in R, I run the New York Open Statistical Programming Meetup, otherwise known as the R Meetup. And I teach R programming at Columbia University as part of the Intro to Data Science course. In this series of videos, we take a tour through just about every aspect of R, from the very basics to complex modeling. These live lessons have a broad audience. It is meant both for people learning to program for the first time and serious code slingers with knowledge of other languages. Expert Excel users looking to make their lives easier by automating tasks through scripts will greatly benefit from this series. And of course, statisticians, old and new, will gain a lot from learning R, whether it is their first language or they are transitioning from SAS, Stata, or another package. We start at the very beginning, downloading, installing, and getting used to the R environment, including RStudio. Next comes the basics, such as variables, data types, vectors, and basic functions. These are the building blocks that make up more advanced structures, such as data frames, matrices, and lists. It is the data frame in particular that makes R so natural for working with data, with its spreadsheet-like mixed type structure. All of R's analysis capabilities depend on its ability to read data from various sources. We explore reading CSVs, databases, and other sources. Once we have data, the first step is visualizing it. While we spend a good chunk of time dedicated solely to graphics, we demonstrate plotting throughout the whole series when appropriate. Visualization is so important to the statistical process that it comes up repeatedly. To really harness the power of R, we need to learn how it handles the basics of programming, such as writing functions, if statements, and loops, even if loops are discouraged in favor of vectorization. Before we can analyze data, we usually need to get it in shape, which is often 80% of the work. We learn all sorts of techniques for munging data using built-in functions and the plier and reshape2 packages. With all of today's unstructured data, it is important we know how to manipulate strings, both for creating them and extracting information. Finally, after all this work, we can get to some basic statistics, such as averages, standard deviations, probability distributions, and t-tests. This is all in preparation for the workhorse of statistics, regression. Linear models and their generalized extensions are covered in great detail with just a little theory to supplement all the computation. After this, we are ready for even more complex models, such as the elastic net, Bayesian regression, and splines. Time series gets plenty of attention as we look at ARIMA, VAR, and GARCH models. Our foray into unsupervised machine learning covers k-means, k-medoids, and hierarchical clustering. At the end of any good analysis, the results must be reported in a compelling fashion. Thanks to knitr, R works incredibly well with LaTeX and Markdown for creating great-looking reports, websites, and slideshows with statistical results automatically embedded within. Lastly, we take a look at building an R package for modular portable code and giving back to the community. I hope you will find these lessons informative and entertaining as you walk through the world of R.